Hi, this is François Normandin, and this is a presentation of the Cron Scheduler offered by LabVIEW open source project. You can find the project on GitHub, and what I'm going to demonstrate now is installation and a quick demo. So first off, open VI Package Manager and search for open source. The open source projects will be listed, and in there you can find the Cron Scheduler. Now it's not published yet, it's going to be published today most likely on VIPM.io, so stay tuned, but I'm going to install it. It's a small project, so it shouldn't take too much time to install. I already have the dependencies installed, which are, if I'm not mistaken, Unicity, OpenURI, actually not OpenURI, and Epoch date and time. So the dependencies of the Cron Scheduler are Epoch date and time and Unicity package. Okay, Cron Scheduler has been installed. So for those of you who are familiar with Linux, Cron is a piece of software that is available for automating tasks. For example, run this task every hour or every day at this specific time. And so this is what this library does. Starting with a blank block diagram, let's go and find the open source project palette. As you can see, there's a Cron Scheduler tab, and in there, let's go through the palette first. We've got a few Cron utilities that are basically shortcuts to allow you to determine what is the next timestamp at which a job is going to be run. And as you can see, there's a Quartz compatible expression parser, there's a Jenkins compatible expression parser, and there's a Unix compatible expression parser, which is, for those familiar, roughly speaking, Crontab. There are some advanced cron utilities, and inside it's essentially the object with the palette that is wrapped into these three nodes. So if you want to dive into those three nodes, how they work, you're gonna like to explore this palette here. There's a tree view, and the tree view explores the everything that is available through the public API, job reports, job classes, both utilities, and how to use the Quartz compatible, Unix compatible, and Jenkins compatible expressions. This is probably a good time to show what are the kind of expressions that Cron is all about. So it's expressions that so Cron expression is just a representation in a string-based representation of a script that. So Cron expression is a string-based representation of an occurrence of the next iteration for a job. So for example, let's say right now it's 3 p.m. And I want to start a job at 4 p.m. every day. Well, at 4 p.m. every day, if I have a Quartz compatible expression, I'm going to have to say that this is, okay, 4 p.m., so that's 1600 hours, and every day of every year, essentially. Okay. Too complicated. So I won't be explaining what the Cron expression is. I assume that if you're interested in this topic, you already know what it is, but I will refer you to if you want to know what it is about from the beginning, you can look into Wikipedia and type cron expression. You're going to find the origin of those strings here. But as you can see, this one, if I were to spell it out, it would be that we want to run a job every day at 10:15 a.m. This one here is just showing an invalid cron expression. The H that you see here in Jenkins, if you use Jenkins for your CI servers, H is a hash, and that will be interpreted based on the job name as a way to distribute the load during the day. So I see that I've made a mistake. This is not supposed to be the Unix node. It should be really the Jenkins node right here. So I'm going to need to fix this into the next. I'm going to need to fix this in the next revision of the library. Okay, so let's close the tree view and get on with the demo. Okay, so quick demo of a cron job launcher. I'm going to create a VI and start in my Cron Scheduler tab here, not tab, but a palette, to use the cron basic job execution. And this is a very simple template that will provide you the ability to run a single job at a time. So it's not a scheduler with multiple jobs. That is not yet part of this library, although I will be working on this in the coming weeks and most likely release something during spring. However, I'd be very interested in getting feedback from any potential users of this cron job and cron scheduler library to see what makes sense for you, what you would think good scheduler functionality would be, and maybe even discuss what type of API that we expect from a user perspective. So I'm going to use that in some of my internal projects and see how it goes. Of course, I'm going to develop some feel for what a good scheduler API should look like, and then I'm going to propose something. So please stay tuned. But in the meantime, what I can say is that this VI here that is dropped VI content directly from the palette is already functional. As soon as you drop it there, it's going to run a VI that is a test VI. So this test VI here is an example job static VI reference VI, and there are some comments here and there, especially about all these here are completely, all these terminals are completely optional. You can put them, you can have them named differently. There's a whole lot of things that are possible with them, but at the base, it's really just launching a VI asynchronously, and therefore you don't need any of those gizmos. If you use them, then of course you get some things that this little job launcher framework allows you to do, which is get some data in and get some data out of that VI, which obviously you want to get feedback and some visibility into your task as they're running. So also you can see that there's nothing connected to the campaign. It's absolutely not necessary. Actually, I'm not looking at the campaign at all during this. Okay, this VI is doing very simple thing, just opening and closing the front panel, monitoring the check abort condition, so the abort notification that can be sent by the UI, and I'm going to make that demo. So every 10 milliseconds, I'm doing a check, and we're just stopping this loop as soon as we reach 5 seconds maximum. So that will give me 5 seconds to either run the demo through or to abort it in midway. And well, here I decided to compute a standard output every iteration, so I will get a partial answer when I retrieve that, whether I abort it or not. I should get the standard out that is not empty. Of course, you can put the standard out as you wish and just fill the answer only when you're ready. But that that's really just for demo purposes. And at the end, what you see here is that I've got a node that is injecting a response, actually, custom parameters that you'd like to report. And so underneath there is just a variant attribute container, and you can pretty much add whatever you want. At the end, in the scheduler, the job scheduler, we're going to see that we have, so let me defer that. We have in the job event, so we retrieve the map, which is all the parameters that you've sent, that you've added, and a job report. So the job report will contain things like its GUID, unique ID, and duration, exception code, and whatever you've decided to pass in and out for post-processing. The map will contain all your custom parameters. So let me put that here in the corner, take less space. All right, so in the timeout case, we are calling the asynchronously or synchronously. So you can decide. You can send a command synchronously. Synchronous means that this node will wait for the job to finish executing before it outputs a standard output and a job report directly. Now, I prefer to send them asynchronously, and that's why there's a job unique ID that is reported instead, because we don't have yet the standard output, and we don't have yet the job report, obviously. So these will be these will arrive in that job report event that I registered for right there. So job report that we've seen, including the map. So that's going to be part of the report that is being sent from both synchronous and asynchronous. So if you are running synchronously, you don't have to register and get it, because you get it straight out of the synchronous node. But if you do register, you can get it both ways. Particularly interesting, when you want to continue to do some other stuff while you're waiting for a result. Obviously, I've made this arrangement so that I can create a job scheduler that handles multiple jobs in the future, which is the part that is not already part of this Cron Scheduler library. Okay, when you do change the cron expression here, you can do that live. We're going to rearm the system, and arming the system just recomputes the next occurrence of the next occurrence of the job, and the way that this VI is done is that it takes now as a reference if you arm it, but you can also compute multiple in advance, where you would put that in a loop and just piggyback this right there with a feedback node, and you would be essentially computing the next. You can also set the number of occurrences. If you want it to be computed internally, you can set, let's say, 4, and you're going to get an array of 4 occurrences, starting with the first one, the next one right there. So both ways are doable. And for this, well, you have to choose which expression parser you want. So by default, I use the Quartz compatible cron expression, and the reason is that is with a 1 second resolution, whereas the Jenkins and Crontab Unix, which is for those familiar with Linux systems, Crontab that comes in pre-installed with I guess most Linux flavors, is also a 1 minute resolution. All right, so for this demo, it was better to have a second resolution, so that I can run it faster. stop just aborts and destroys the job, and finally, monitor here checks how many milliseconds between now and the next occurrence. So if you are in the process of doing some other things, you can do it and come back to that idle node, and it's going to compute how much time has lapsed, and report how many milliseconds to wait until the next timeout case. Now, if you've done a task synchronously here, and it become negative, now the next event is going to be 0, and you're going to launch it right away. So this you've got to be aware that this node here, if you send something in the past, a timestamp in the past, is going to report you 0 by saying, yeah, you should really be doing it right now. You're already late. All right, so there's a abort job, and there's also a kill job. So kill job is going to try to abort it, and after something like 50 milliseconds, it's gonna just kill the thread. Now, abort and kill will not work if you are using synchronous. Synchronous will continue until the sub process, the job itself, is finished. So that's because there's no way to kill off the process without killing the scheduler as well. If you're running in the same thread, it's gonna just abort everything all at once. So for any jobs that you intend to be able to abort, I strongly recommend the asynchronous payload, not payload, but a method. Now, why I'm saying this is because under the hood, it's really just a wrapper on the synchronous call. So you lose absolutely nothing by doing that. You can launch that because it's launched with a VI server call and forget here. Inside the node, we can do a monitoring of a watchdog, and if the watchdog is either destroyed, that would be to kill the process. Now we can stop this thread completely, only if it's asynchronous, because if it's not asynchronous, then this would also kill the caller, which is really not in our interest to do that. You really need to do a proper shutdown in those cases. So if it's asynchronous, if it's not asynchronous, it will not do anything, and if it is synchronous, then we would try to abort first and then stop the thread altogether. Okay, demo time. So I'm going to close this for now, and let's just start running this. So every 10 seconds, you're going to see a pop-up, and that pop-up is the example window that we have. So I'm going to move that aside, and you see that it lasted for 5 seconds. There's no exception because there was no error running it, and the last value is reported here and in the random attributes that I've set. Now I'm going to just abort this one, and as you can see now that I aborted after 2 seconds, I get an exception code, and I get a partial value that was also set. For those of you who would like to know what the exception code is, there's a node for that. It is right here, explain exception code. And I'm going to just stop this and maybe get into my job event report. Just see what's going on there. Sorry, I don't have much room, so I'm going to just go weird around, and I'm going to have an exception message. By the way, the exception message is computed from a overridable method, meaning that if you are overriding the job into something else, well, you can determine your own job exception codes. Okay, so that exception code, when I run it and I abort, should just tell me that it's aborted. There you go, job aborted by caller. By the way, this is a warning, this is not an error, because, well, if it's been aborted by the caller, it's kind of a voluntary action. It's not like I killed the job or something like that. So, oh, it finished before I was able to kill the job. Now, killing the job will report that it's been aborted because I successfully aborted. If I didn't have this abort monitoring, or if the abort monitoring was too long, meaning that more than 50 milliseconds would have passed, then it would probably have killed the thread, and that would have been that. Okay, last exercise that I'd like to demonstrate is how to generate your own VI to do your own tasks. There are two things that you can do. You can either look into the job templates right here, and the job template allows you, when you are into a new VI, to just drop either of these templates, and that's probably a good time to show you the difference. Like I was saying that there was no need to have all the nodes. Like here in this second template, you can see that there are no job in and job out. So that means that it's impossible to add any data. All the communication will go through the standard input and output, and I cannot add anything to the map, and I cannot check for the abort. Well, that's okay. Here I've got a job complete, and all I can say is just done, and that's it. I'm going to come back to that other VI right there, because there's another way to instantiate it. Okay, so my job here, very simple job. I'm going to make that much smaller. Sorry about lagging. I'll delete the comments and I won't even save that. However, I'm going to just drop it here and see what happens. If it, well, it already worked once, so you see, it just said done. That's what I expected, and I can do whatever I want. See, it ran on me quickly. Thing is, you can have it set as reentrant, non-reentrant. Execution, this one is non-reentrant. If I call it reentrant, and it still works. So I can really toggle between reentrant and non-reentrant. It's going to be handled by the job launcher. Might be a good idea to stop before I leave. I make this VI leave memory. So what I'd like to show you now is a different way to create a template. You will have to go to Tools menu. Tools menu in the LabVIEW open source project. You have the Cron Scheduler and create job VI from template. You've already seen the template. Basic job template is exactly that. It has a nice icon now, but that's about all there is. Yes, you can leave memory. All right. And so now I'm going to play a little bit with this so that I can show you what is going on. The first thing we're going to do is open our VI in step 1. That's going to be front panel open. In my step 2 of my state machine, I'm going to have a wait for, I don't know, 2 seconds, just to allow me some time to abort the job before I reach complete. And complete would, in this case, close my VI. So why am I doing this pattern here? It's because what I expect as a result is that if I were to abort during step 2, right there, so I'm going to stop the loop without going to the complete step. So if I don't complete, then it means that I will not have this message. Job complete, and I will not close a VI. However, I'm going to remove this and send the notification of why not have a boolean that says aborted or not. I will not save this because it's just a demo. Now running this, I'll leave it to work and finish. So job complete, aborted false. That's perfect. Now next time I'm going to abort the VI, and I abort it. It will finish, as you've seen, it finished. It's 2 seconds wait because that was a synchronous wait, but at the end it aborted with a warning 42003. That's what I get as an exception code, job aborted by caller. My standard output is empty, but my attribute is now set to true. So you have a lot of flexibility here in how you deal with your jobs. All right. Well, that's all for that demo. I hope it was informative. If you want to know more about the Cron library, you can go into GitHub, LabVIEW open source /Cron, and I mean, look at the issues. There's some documentation that I've put there right now, some discussions about the templates. There's a depiction of the tree view that is in there, and that's also, I think there's a wiki page, Open Cron Library, which is kind of a high-level presentation, how it works behind the scenes. So, and there's an error there. I'm going to correct that. So, wide intermediary representation. You can ask yourself how it works to have different compatible expressions. I have my own expressions and my own syntax that I'd like to support. Well, how do you want, how you can create your own expression? It's all, object based, and so you can dive in and see and build from your expressions and map it to the intermediary representation that and that tells you how to override the two different methods that you need. A few examples of what is for example, this what does this expression mean, and how it's mapped to the intermediary representation. So you can see some examples here. If you do have questions, don't hesitate to just create an issue, and I'm going to try to address it as quickly as I can. All right, thank you very much.